Angle relationships when parallel lines are cut by a transversal. All right, let's review. Parallel lines mean two lines that go in the exact same direction, and that if they would go on forever, they would never, ever, ever intersect each other. The word transversal is referring to the line that crosses over, intersects both of those parallel lines. And I want you to realize parallel lines don't always have to go left and right. Parallel lines could go up and down, they could go diagonal. But no matter what, the transversal is referring to the line that intersects over the two parallel lines. All right, now please note, I'm going to be showing you a lot of vocabulary and a bunch of examples, and all of them are going to use 115 degrees and 65 degrees every single time. That does not mean that these types of angles always equal 115 degrees or 65 degrees. It could be any number of degrees. I just wanted to give that pre-qualifier here. All right. First type of vocabulary that we're going to talk about from parallel lines cut by a transversal, corresponding angles. They are a pair of angles in matching positions. Here's what I mean. The 115 degree angle up here is on the top right hand corner, and if I slide that down the transversal, you will see is in the matching position of this 115 degree angle, also in the top right hand corner, but in the bottom part of the picture. They are in matching positions, and you'll notice they are congruent to each other. Congruent means having the same measure. Here's another example. Over here in blue, we have the 65 degree angle in the bottom right hand corner of the top part of the picture, and if I slide that down the transversal, you will see down here in the matching position is this other 65 degree angle, also in the bottom right hand corner. They are obviously congruent. This is what I mean by corresponding angles, being in matching positions. I could have also chose the angles in the top left-hand corners. I could have chose the angles in the bottom left-hand corners. Alternate interior angles are a pair of angles that are inside the parallel lines. Now, when I say inside, I mean between the parallel lines. But it should be noticed they're also going to be on opposite sides of the transversal. Here's what I mean. You can see these two angles that are both 115 degrees are on opposite sides of the transversal, and they're both between the parallel lines. They are a pair of alternate interior angles, and you'll notice they're the same measure. That's what congruent means. The other pair would be these two pairs of 65 degree angles. Notice again, they're on opposite sides of the transversal, and they're both between the parallel lines. That's another pair of alternate interior angles. Alternate exterior angles are a pair of angles that are outside the parallel lines, but on opposite sides of the transversal. Here are my two examples. The 65 degree angles that I have here are both on the outside, the exterior. They're up at the top and down at the bottom, and they're on opposite sides. Here, the 65 degree angle on top is on the left. Here on the 65 degree angle is on the bottom on the right. Those opposite corner angles are a pair of alternate exterior angles. Notice they are the same measure, which is what congruent means. The other pair here would be the 115 degree angles, both on opposite sides of the transversal and both on the outside, up and down from the parallel lines. You can also find pairs of vertical angles and supplementary angles at multiple locations when you have parallel lines cut by a transversal. You recall from our other video, vertical angles are opposite angles formed by intersecting lines, and they are congruent. Supplementary angles are not congruent, but they are two angles that together would add up to equal 180 degrees. You'll recall any type of straight angle will be 180 degrees. So if you see two angles that are adjacent side by side that together form the straight angle, they will add up to equal the measure of the straight angle, which is 180 degrees. That's what we mean by supplementary angles. And there's many different pairs of supplementary angles and many different pairs of vertical angles that you can find in these types of drawings. All right, first set of examples given. The yellow highlighted lines here are parallel. First problem. If the measure of angle 1 is 119 degrees, let's find the measure of angle 2. All right, how are we going to do this? Well, we know the measure of angle 1 is this obtuse angle here on the top left-hand corner. And if I slide that across the transversal, I will see it is in a matching position as angle 2. Angles in matching positions are called corresponding angles, and we know they are congruents, which means the measure of angle 2 is equal to the measure of angle 1. Since the measure of angle 1 is 119 degrees, the measure of angle 2 is also 119 degrees. Now, let's change this up. Here I'm saying if the measure of angle 1 is 119 degrees, find the measure of angle 3. All right, here's the relationship of angle 3 and angle 1. Let's see if you can notice this. They are on opposite sides of the transversal. Angle 3 is below, angle 1 is above, and they're both on the outside of the parallel line. So out on the left and out on the right. Whenever you see angles like that on opposite corners, both on the outside, opposite sides of the parallel lines, they are going to be a pair of alternate exterior angles, which means they are congruent, same measure, and therefore the measure of angle 3 is also equal 119 degrees. You might have also noticed that angle 2 and angle 3 were congruent to each other because they are a pair of vertical angles formed by two intersecting lines that I've highlighted for you here in yellow. Opposite angles formed by two intersecting lines are a pair of vertical angles. Another way that you could see that angles are congruent to each other. All right, let's change the way the angles are numbered. Now, if the measure of angle 1 is 119 degrees, find the measure of angle 2, which is now at a different place than it used to be the other way I had this drawn. How do I do this? Well, the measure of angle 1 is clearly an obtuse angle, 119 degrees. The measure of angle 2 does not appear to be obtuse. However, notice those two angles are adjacent to each other, right next to each other, and they together would form a straight angle. Why do we care? A straight angle is 180 degrees, which means we have a pair of supplementary angles, two angles that add together to equal the measure of the straight angle, which is 180 degrees. So, if the measure of angle 1 is 119, we can subtract that away to get the measure of angle 2, which is 61 degrees. Now, this time, let's say the measure of angle 2 is 61 degrees, and I'm going to ask you to find the measure of angle 3. How are we going to do that? Well, the measure of angle 2 and the measure of angle 3, take a look at them. They are on opposite sides of the transversal, so angle 2 is above, angle 3 is below, and they're both between the parallel lines. This is what we call a pair of alternate interior angles, which happen to be the same measure, congruent. So therefore, the measure of angle 3 is also the same measure as angle 2, which is 61 degrees. All right, let's make it a little bit more complex. Take a look at this diagram. Here we are given that A and B, which are representing lines, are parallel lines, and they're asking us to find the value of x. How are we going to do this? Well, angle that's x degrees and the angle that's 70 degrees, they do not appear to be congruent. In fact, x degrees definitely appears to be obtuse. So I'm not going to say that x is 70. However, the angle that I am now showing you here is a corresponding angle to the x degrees. So that up there could be x degrees. Do you start to see what I'm noticing here? That 70-degree angle and x degrees are actually a pair of supplementary angles because they together would form 180 degrees, a straight angle. There's another way I could have looked at this. I could have said that x degrees could also be this top left-hand corner angle because that angle up there and the original x degree angle down here are a pair of alternate exterior angles, therefore having the same measure. And so I can look at it this way, that x and 70 are a pair of supplementary angles forming a straight angle going horizontally here. So either way I look at this, supplementary angles are two angles that add up to equal 180 degrees. So I can take the 70 degree, subtract it from 180 to solve for x. I get the measure of 110 degrees.